All right, this is the answer key video for the lesson 8 and 9 study guide. Okay, so for this one here, I am going to start with the document completely blank, okay, because I feel like I want you to see how exactly I'm working this process rather than just, again, seeing the answers here. All right, so this video is going to be a little bit longer, and I do apologize for that, but I feel like it is really worth going into it one more time because we are going to take our big summative on these 2 units here, okay? So the first 2 problems here are talking about piecewise functions, okay? So that's from lesson 8, okay? Now, you're asked to graph the different pieces, all right? So we're going to look at this first one, okay? So essentially, if we remember what a piecewise function is, okay, there are 2 different pieces, okay, or 2 different rules. And when those rules apply is on these if statements or these for statements, okay? So this rule of f of x is equal to 2x plus 6 applies for when x is less than negative 2, okay? So in this first problem, we're asked to just graph that. Okay, now I'm going to show you the way of how to graph it using the equation. All right, you are also, of course, welcome to use your graphing calculator to plug this in and to find the coordinates, but I'm going to show you how to do it with the equation. All right, so essentially, this is a y equals mx plus b equation. Okay, and it's y equals 2x plus 6. Okay, so what that means here is that we start at 6 and we have a slope of positive 2. So that means we go up 2 and right 1, since it is rise over run. Okay, in the opposite direction, down 2, left 1. Okay, ooh, went too far on that one. Down 2, left 1. All right, so if we were to sketch just this line, okay, it would look something like this, okay? But we look at the back half of this rule, okay? For when x is less than negative 2. So we're talking about right here, okay? So this rule only applies when x is less than 2, specifically negative 2. So what I'm doing here is I'm erasing, obviously, up until negative 2. Now, at negative 2, the question is this going to be an open or closed circle? And since it is just less than and not equal to, that means this has to be an open circle at negative 2. Okay? So that's what that piece of the graph looks like. Now, we look at our second piece. When f of x is equal to x plus 3. So y is equal to x plus 3. Again, what that means is we start at 3 and we have a positive 1 slope. So we go up 1, right 1, up 1, right 1. And our graph would look like this, right? And our line would, of course, look something like that. Okay? But now we look at the back half. For when x is greater than 3. So x is equal to 3 here, so we go up and we are going to that point. And since it's greater than, it's got to be to the right of. So what we're going to do is we're essentially going to erase all the way up to that point. Now again, open or closed circle, it's going to be an open circle because it is just greater than. If it was greater than or equal to, then it would be a closed circle. All right? But those are the 2 pieces to our function. Done. Okay? That's it. So now let's go to the next piecewise function. Again, there are 2 rules, meaning there are 2 lines. Okay? This one is potentially a little bit more involved. So let's look at the first piece. X plus 5. So y is equal to x plus 5. All right, so we go up to 5, right? And we have a slope that goes in this direction and in this direction. Okay, so it is a slope of 1. So up 1, right 1, or down 1, left 1. Okay? Now, since we know we have this back conditional part here, I'm not connecting it with a line just yet. Okay, so this is actually going to be a line segment because x is between these 2 points. So x is when we're between -2 and 1. So we're specifically going to look at this point here and this point there. Okay, so anything outside of those points we get to erase because x has to be between them. Okay, now we look at the first point, -2. Since it is less than -2, open circle. If we go up to 1, it is less than or equal to our 1. So that's going to be a closed circle. All right. So again, x is greater than -2, but less than +1. And we connect all those points with a straight line. Okay, again, open circle because it's just less than, closed circle because it's also equal to. All right, now let's look at the second piece. Y is equal to -x plus 3. Y is equal to -x plus 3 for this x value set. Okay, so we're specifically looking between 1 and 5. All right, now -x plus 3, so we're going to start there. And our slope, since it's -1, we go down 1, right 1. Okay, down 1, right 1. And again, since we're only looking between there, we can erase this first point here. Okay, now again, the question is open or closed circles. Both of these are actually not including that point, so they're going to be open circles at both of those. All right, we connect them with a straight line. That is our line segment for the second piece, or the second rule of this function. Okay, and again, of course, you're welcome to plug these into your calculator, hit the second table button, and then get your XY coordinates and plot them. Okay, and then obviously erase for where the conditions don't apply. By conditions, we're talking about those if statements or for statements. For when x is something. Okay? So that's how we graph piecewise functions. All right, you do it piece at a time. You make sure you have the right line, and then you constrict the line to where the conditions tell you. Okay? The next two here are using the piecewise function rules to solve for answers. Okay, so what this is saying, it says find f of 3. So what that's telling us is normally that's f of x. So this is saying that x is equal to 3. Okay, now where is x equal to 3? Which of these two rules? Okay, so we're going to have to do this rule. Okay, because x is less than or equal to 3. So that means we are using that rule. So f of x is equal to x plus 1. Now, specifically, we're looking for f of 3, which again means that x is equal to 3. Okay, that's what f of 3 means. So we are going to replace our x with a 3 plus 1. Since we don't have anything to multiply by, this turns into 3 plus 1. So f of 3 is equal to 4. So our final answer is that f of 3 is equal to 4. Okay, so again, what is this asking? This is saying find when x is equal to 3, what is that y value? So f of 3 is equal to 4. We go up to this rule, we plug into this equation, and we solve. All right, now let's try it again for the second one. Find f of 4. Okay, so find f of 4. All right, so that means that x is equal to 4. So where does x equal 4 fall? Okay, and it's not this one because it's not less than -3. It doesn't fall between -3 and +2. It is right here. Okay, so x is greater than 2. Okay, another way of saying that is 4 greater than or equal to 2. Yes, therefore we use this rule. Okay, so we rewrite our equation. F of x is equal to 5x minus 19. Specifically, we're looking for f of 4, which means x is equal to 4. We replace with the parentheses. Okay? Then we just solve. So f of 4, 5 times 4 is 20, minus 19. We drop that down. 20 minus 19 is 1. So f of 4 is equal to 1. So again, equals 1. What that means is we have a coordinate at 4, 1. All right, our x value and our f of x value, also known as your y. All right, evaluate this function graphically. So we're asking a similar thing to this, but now instead of having to plug into the piece, okay, we're looking at it on the graph. So find f of 6. That means x is equal to 6. So we go to where x is equal to 6, all right, and we have 2 points. We have a point here and a point there, okay? Now, the question becomes, which one do you use? Okay? And we have to pick the one that is the closed circle. So we are specifically looking at this point right there. Okay? So that is at the point 6, -2. So what is f of 6 equal to? -2. Again, this is like saying, what is the y value when x is equal to 6? Okay, and the trick for that one is closed circle versus open circle. All right, now the next one here, find f of -1. So when x is equal to -1, y is equal to, we go to -1, and we have 3 potential values. There, and there. But again, we can only use the one with the closed circle. So we're specifically having the value at -1, +2. So when x is equal to -1, y is equal to 2. So f of -1 is 2. All right? So that's it for that one. Okay? Now, moving on here, we're looking at Unit 9. Unit 9. Okay, so that was solving our system of equations, right? Looking for the XY pair that has where these 2 lines cross or these 2 lines meet. Okay, so there are 3 answers to these questions always. A specific XY coordinate, no solution, or infinitely many solutions. Okay, so let's take a look here. The first one says, solve the following graphically. Okay, so that means in order for us to graph, we have to get into y equals mx plus b equations. Okay, so this first one here is a y equals mx plus b equation. So you can plug that into your calculator, just like you did for the piecewise. You can get out these values, okay, and solve. Okay, so if we start our plot here, we go up 2, okay, and then our slope is a -1. All right, which is like saying again, down 1, right 1. Okay, there, continuing forever. Same thing in the opposite direction. Again, negative slope should be going downwards. Okay, connect them with a straight line or roughly a straight line. There you go. All right. Then we got to look at the second piece. Okay, and this one is not in a y equals mx plus b form. So what we're going to have to do is we're going to have to rearrange that to get that into y equals mx plus b. Okay, so we're going to subtract 2x from both sides. Negative y is equal to -2x plus 7. Now, it says y equals, not negative y. So we have to divide everything by -1. So this turns into y is equal to a positive 2x minus 7. Okay, so we start our graph down at -7, and we have a positive slope. which is 2 over 1. So we go up 2, right 1, up 2, right 1. Okay, and obviously you can see where we are going to cross the other graph. But we draw our line, put arrows at both ends, okay, and we can clearly see we're going to meet right there at that intersecting point. Okay, and that point is at the coordinate 3, -1. So that is the answer, 3, -1. We have one solution right there. Okay, now let's try it again. Okay, first equation here, y is equal to 1/2 x plus 7. So our slope is equal to 1/2. That means up 1, right 2. And we're going to start when x is equal to 7. Or sorry, when y is equal to 7. Apologies. Okay, when x is 0, y is 7. All right, so then we go up 1, right 2. All right, and then we go in the opposite direction. Down 1, left 2. Okay, we connect those with our straight line. Boom, boom, arrows both sides. Okay, then here. That one is clearly not in y equals mx plus b form, so we've got to rearrange just like we did last time. -3x minus 3x, y is equal to -3x minus 7. Okay, so that one is good there. So if we go down to -7, okay, and we have our slope of -3x. So that means -3 over 1, which means down 3, right 1, or the opposite, up 3, left 1. So there, let's try it in the other direction. There, there, there. Okay, connect with a straight line. Good. All right. Then obviously we can see we're going to cross at that point there. Okay. So we are going to cross at the point -4, +5. Okay. So that is our answer. We have one solution that crosses right there. Okay. Now, something I want to give you a hint for. If you're not crossing at specific points, okay, whole numbers, your answer is wrong, okay? If on your test you are getting fractions of answers, that's probably going to be wrong, okay? All of the problems we have done, when you have a point, it is a whole number, okay? So if you're drawing your graphs and you're pretty close to a whole number but not exactly on it, check to make sure, okay, that it's not just your graphing skills, because if you're really close to a whole number, it's probably just that whole number. Okay, but if you're crossing through a halfway point, okay, so if you were crossing like there, that means something's wrong, okay? So your answers should be whole numbers. All right, now let's go on down here to our next method of substitution, okay? So if we are going to substitute, all right, we are going to place one thing into the other. So this one here, you've got y equals by itself, okay? And that's what we need for substitution. We need a y equals or an x equals all by itself. So what this is saying here is we're going to sub that in right there. So what I recommend you do is you rewrite your original equation without substituting first, okay? Now we substitute in for our y. Okay, so we have 2x plus 2y, but y is equal to 4x. Okay, and now if we look, we only have the x variable. So we have one equation and one variable, we can solve this. Okay, so after we replace, we distribute 2 times 4x, which is 8x, and we drop everything else down that is untouched. Okay. Then we combine our like terms. That turns into 10x equals 50. Okay. Then we solve for x by dividing by 10. X is equal to 5. Okay. So that's our first answer. X is equal to 5. Now you take that x is equal to 5 and you're going to plug it back into one of these equations, and we have to solve for y. Now, doesn't really matter which one you pick. However, the second equation looks a whole lot easier than the first. So I'm going to rewrite my original. I need to replace right there. So when I rewrite y is equal to 4 times x, x is equal to 5, we replace, we distribute, y is equal to 20. There's our final answers. We have one solution that crosses at the point 5, 20. Done. Okay. Y equals 20, x equals 5, xy coordinate. Okay. Now the next one here, solve by elimination. Okay. So for elimination, you have to have your variables matched up. Okay. You have to have your variables matched up. So if we look here, our y's are not matched up. So we have to rewrite one or both of these equations. So what I choose to do is I'm going to rearrange my second equation. Okay, just for the sake of argument here. So I got to get my y by itself, or on the other side, negative 3x minus y equals. Now, if you get down to something here where everything cancels out, you still have to have that equal sign. You need to make that equal to a 0. Okay, you make that equal to a 0. All right. So then whenever you have to modify an equation, I always recommend that you write both of them again before you try to start replacing. So we said this is negative 3x minus y equals 0. Okay. Now we double check. Are these matched up? Yes. Are these matched up? Yes. Are those matched up? Yes. Okay. Now, elimination says that we need to get rid of one of these variables, okay? So we then look and we say, okay, do we have any common coefficients? Well, that's 9x and 3x. That's not the same. I've got 2y and 1y. Those aren't the same. So now we have to ask ourselves, okay, I got to cancel out at least one of these equations. So I'm going to choose this one. Let's look for y. Okay, so how do I turn a 1y into a 2y? I multiply this entire equation by 2. Okay, so if I distribute 2 times negative 3x, that turns into a negative 6x. 2 times negative y is a minus 2y equals 2 times 0, which is still 0. Okay, then I need to take my other equation and drop it on down again. Okay, or if you like it in that order. Okay, so we've rewritten them for a second time. Okay, now that I'm looking at my y's variables, 2y and 2y. Okay, so the question becomes, do I add or subtract? Okay, and one of the tricks I like to do is I sometimes just write it over on the side. 2y something negative 2y, I need that to cancel out and equal 0. Okay, so the question is, am I going to add or subtract them? Well, if I added them to negative 2y plus negative 2y, that would be subtraction. Negative 2y minus 2y is negative 4y. So I actually need to subtract. Okay, and I know people have issues with this. So if it helps you, get rid of the variables. Okay? Get rid of the variables. Negative 2 blank negative 2 equals 0. If you plugged into your calculator negative 2 plus negative 2, that's going to tell you negative 4. But if you plug into your calculator negative 2 minus a negative 2, that's going to tell you 0. Which should mean then that this becomes a negative. So we need to subtract our second equation from our first equation, okay? And we do this subtraction for every single pair. So this logic over here, you're welcome to use for every single pair. My x's, my y's, and my numbers, okay? So negative 9x minus a negative 6. Okay, that is like saying negative 9 plus 6. So that's going to give us a negative 3. Negative 3 what? negative 3, x. Okay, then we already know our y's cancel out, and negative 12 minus 0 is still negative 12. Take it both sides, divide by negative 3, x is equal to a positive 4. Okay, now that we have x equals to a positive 4, we need to plug that back into any equation and solve for y. So we could plug it in here, there, back in the original, or we could even go back up to one of these originals, there or there. Okay, so maybe I want to plug it in right there. Whatever you choose, I recommend that you rewrite your original equation, whatever it is, even if it's this red one, rewrite it before you replace it. Why? Because we have a hard time with organization. And organization is going to make sure that you get all the points that you deserve. Okay? So if you didn't rewrite this and somehow you forgot the negative sign, you can't get full points. So make sure that you rewrite it so we know exactly what we need to do, which in this example is negative 3 times a positive 4, which is negative 12, equals y. So our final answer is we have one solution at 4, negative 12. Okay, we have an answer at 4, negative 12. All right, so those are our other two methods. All right, then if I don't specify, it's a choose your own adventure. Okay, so in these here, let's see if there's a method that looks easier than the other. Okay, so neither one of these are in y equals. Okay, but I do see that this x is by itself. So for this one here, I'm going to choose a substitution method. Okay, so what I'm going to do is I'm going to take this equation and rewrite it to get x by itself. So x plus 14y equals negative 9. I'm going to subtract 14y from both sides. X equals negative 14y minus 9. Okay, so again, that becomes my new equation. And the other equation is untouched. 6x minus 7y equals 37. Okay, now I'm going to substitute. So I'm substituting this in for where we see x. Okay, so if I rewrite this equation down below to start solving, I'm going to replace for 6x. So 6 times what x is equal to, which is negative 14y minus 9. Keep going. Minus 7y is equal to 37. Okay. Then after I replace, I distribute. So 6 times negative 14 is negative 84y. And 6 times our negative 9 is negative 54 or minus 54. All right, then we drop down our negative 7y and our 37 because they're untouched. Okay, then from there we combine our like terms. And our like terms are the y's. So it's like this doesn't even exist. So negative 84 minus 7y gives us a negative 91y. Okay. All right. Then we drop down everything else. Minus 54 equals 37. Okay. Then we got to get y by itself. So undo the minus 54. All right, so we end up with negative 91y equals a positive 91. Divide both sides by negative 91. Y is equal to negative 1. Okay. Now that we've got our y value, we can plug it back into any of these equations. There, the original. Okay, however, I like the way that this equation looks because I need to get my answer for x. And since x is already by itself, that's where I'm going to plug in for the y. Okay? So, x is equal to negative 14 times by our new value of y, which is negative 1, minus 9. Okay, so we then distribute. Negative 14 times negative 1 is positive 14, minus 9. X is equal to 5. So we have one solution at 5, negative 1. Okay? You could have chose a different method. Okay? But as long as you get the answer 5, negative 1, that's what matters. Okay? Now the last problem here, again, another choose your own adventure. Okay, so again, I noticed that nothing is in y equals. So for me, since neither one of them are there, I'm probably not going to graph this one. Okay, I do see I have a y variable by itself, and I do see that my x's and y's are matched up. So for this one here, I'm going to choose the elimination method. Okay, and in elimination, we have to get a common coefficient. So 6 and 2 aren't common, and neither is 1 and 5. So the question is, do I want to turn a 2 into a 6 or a 1 into a 5? And for this one here, I'm going to turn a 2 into a 6 by multiplying everything by 3. Okay? So we distribute. Okay, so 2 times negative 3 gets us negative 6x minus 15y equals 18 times 3, which is 54. Okay, so this becomes our modified equation. All right, and since the first equation is untouched, rewrite it. Okay, now in this one here, again, we're trying to get rid of 6x and 6x, but you can see it's 6x and minus 6x. So what we're going to do is we're going to add the bottom equation, okay? So 6x plus negative 6x, those cancel. Y plus negative 15y, that is negative 14y, all right? And then 30 plus 54 gets us 84, okay? Divide both sides by negative 14 to get y by itself. Y is equal to a negative 6. Okay. Then we've got to plug that y back into any of these spots here, okay, to solve for our x. So I'm going to choose this one right there. So rewrite your original equation, 6x plus y equals 30. And we now know that y is equal to a negative 6. Okay, so we drop everything else down. Once we replace, this turns into 6x minus 6 equals 30. Plus 6 on both sides. 6x is equal to 36. Divide by 6. X is equal to 6. So this point here is at 6, negative 6. Okay? So that covers this entire study guide. Of course, if you have questions, please feel free to shoot me an email or come on in for some extra help. Okay? But this covers what you need to know in order to be able to do your test on 8 and 9. This study guide did not have any examples of no solution or infinite solutions. So please make sure you also review those. All right? Otherwise, I'll see you guys later. Thanks.